Okay, cool. Guess, yeah, today's the 12th, so all we have on the agenda at the moment is the agent evals overview. But feel free to add anything. I will drop the link in the comment section. Okay, Christian, I think this is you, right?
Yeah, if no one has any other topics, then I'm happy to start. It's great to meet everyone. This is my first time on this call, but I've been using and contributing to Kagent to some extent since a while now. We also created a project for evaluations. So that's the project that we call Agent UAS. And I will give you a short high-level overview of the project. Why is it different? How is it different than other solutions? How you can use it? What is happening behind the scenes? How you can integrate it with Kagent? Contributions are more than welcomed. And yeah, that's basically it. It won't be a very detailed deep dive, but I'm more than happy to answer questions. You probably will have some because URs and evaluations are, I don't know, everyone has some kind of idea about what they are, but in reality, might not be something that is applicable for all the frameworks and all the various Gen AI workloads. So happy to share more information on our take on it. Cool. I will first share my screen and show you a couple of slides. It's like basically 4 slides and a couple of additional ones, so it's not a lot. How can I share my screen? Hopefully it works. It's pretty rare that I'm on Google Meet calls. One sec, it's not that easy if I want to do this from the browser. Move to window. It's the hardest part. All right. Let's try it again. I think you should see the slide itself.
Yes.
But I cannot really see you, but that's fine. I only need to take a look at the slides. Can you see the other slide as well? The first slide?
Yep.
Okay, cool.
Yep.
So just very quickly, what evaluations are? Evaluations are basically tests for AI systems. I use the term AI system because these systems usually include an LLM in some shape or form. It can be local, it can be one of the big providers like OpenAI or Anthropic or other ones. And you also usually have tool calls. If you have an agentic use case, then you might also have other agents. All of those can call various tools, MCP servers, but usually there's an LLM somewhere, and that plays an important part in the actual interaction that you are trying to evaluate. In the simplest form, you give some input, and we can forget about how many agents and how many tools you have. You have one interface. Through that one interface, you give an input to the system, and you will receive some kind of reply response back. During this conversation, tool calls, MCP servers might be happening behind the scenes. But basically you got some response back. And when you are doing an evaluation, you basically want to evaluate the quality or the actual success of that given output that you are receiving based on the input that you are providing to the AI system. There can be various use cases. In the simple case, you might just have a single-turn conversation. We are talking about a single-turn conversation when you ask a simple question from the AI system, like what's the weather in Chicago today? And you got the actual weather report back. Or you can have a multi-turn conversation when you want to narrow down to some kind of specifics in the actual context that you are interested in, and you want to dive deeper into one specific problem, or you want to do some follow-up questions based on the context that you start to accumulate with the AI system. These are the multi-turn conversations. But you are already familiar with this because this is a Kagent code, and this shouldn't be new to you. And of course, if you have many agents, it can get even more complex. There are online and offline evaluations. Online is basically something quite close to the continuous aspect of certain monitoring related tasks and use cases. So for example, when you are doing continuous, profiling, then you are not just getting a profile dump and checking the actual results of that dump or the actual profile of that dump, but you are doing this continuously. So each time you have a new deployment out of the box, in a periodic way, you are taking the profile dump and you are getting results back, and you have a way of continuously check the results as time and progresses. For evaluations, this is kind of similar. So basically you have, for example, Kagent deployed, you have various agents, and let's say one day a new OpenAI model comes out, or an Anthropic one, or whatever. Once the new model is out, you change your model config and you switch to that model config in your agent configuration, so the agent can leverage the new shiny LLM capabilities that the provider is providing with that model. Over time, you want to see whether the quality of the agentic interactions of that specific agent using the new model are decreasing, or like degrading, or improving. So if you have some kind of online and continuous evaluation implemented, then you should be able to see over time, for example, visualization doesn't really matter, but you can have a graph, a time series chart that will show that, okay, the actual score for some kind of quality metric will go down or it will go up after you made that change. Then you can also do offline evaluations. Basically, after you had an agent having a conversation and doing some kind of stuff, you have some kind of transcript of that conversation. And after the fact, after the actual interaction has happened, you have a way of evaluating that past conversation based on some kind of stuff. Maybe you want to compare that to another run, another transcript, and that other run or transcript might or might not be using different tools added to the agent, or a different model, or a different system prompt, or whatever. Basically, you tune something in the agent and you compare this after the fact. Basically, this is some kind of manual process where you have past runs and you do this on demand, basically. Performance, latency, token count, these are important things to talk about, because after this point, after people start to get some kind of idea about evaluation, performance, latency, token count, these are things that usually come to mind, because these are important things with microservices, but these are not strictly part of evals themselves. Evals are more around the actual correctness and the quality of the output that you are getting. Of course, if you screen a bit, then token count, latency, these are also relevant to the quality, because you don't just want a good answer. You also want it fast. You also want it cheap. You also don't want to pollute your context with lots of noisy stuff in your output. You are interested in getting a concise, to the point output that is doing exactly the thing that you are doing. Usually these are not part of the default EVALs. So for example, if you take a look at other EVAL solutions, most of them won't have this kind of capability out of the box. I will talk about what kind of capabilities they usually have, but the performance-related ones are usually not there. If they are there, then these are provided as some kind of external plugin-like system. And that's actually a quite similar take as to what we are doing with Agent EVALs as well. This was the first slide about what EVALs are and what's in scope. Do we have any questions at this point, or should I move forward to the next couple of slides and do a Q&A afterwards? And I cannot see anyone, so I would need some
Yeah, it doesn't seem like anyone has a question, so yeah.
Okay, cool, yeah, some voices that I needed because I cannot see the screen. Okay, so this slide is basically what's in focus for Agent EVALs, how we build it, and how we are positioning it and focusing it in the actual ecosystem. If you also take a look at what kind of EVAL solutions are out there, for example, there are some LangChain, LangFuse, Comet has a solution on EVALs as well, Brain Trust. There are some players who have this capability. If you take a look at their offering, you will see that many of them have LLM as judge and various flavors of LLM as judge evaluations, which makes sense because that's where all these things started. Back in the day, there was not too many agents running around. Everyone was basically just chatting with an LLM, and they wanted to evaluate the actual LLM itself. And this is what all these LLM as judge flavored EVALs can give you. Basically, you can see in a synthetic way, check the quality of the output of an LLM system. If you have agents, tools, and MCP servers, it gets a bit more complex because you are not just interested in, okay, how does the latest Anthropic model perform compared to the previous one. You also want to get more detailed information, like, for example, after I switch to this new model, is my agent leveraging tools in a better way? Are these agents consuming less or more token? Is it getting faster or slower? These are the things that the LLM as judge metrics and evaluations cannot really give you. Next point is being framework agnostic and fully portable across platform. And this is very important because there are some players out there in this space who claim that, okay, we have a portable solution. You can use any kind of framework. You can use ADK, you can use strands, you can use LangChain. And if you are using those frameworks, you just need to use our SDK and you will get a fully framework and everything agnostic EVAL solution on top of that. But that's the key. You have to use the SDK, and there are many, many SDKs. And coding is getting cheaper and cheaper. Everyone can use and manage any kind of SDKs nowadays. Also, these are Python, and LLMs are quite efficient with Python, but it's not really framework agnostic and not fully portable because you have to use a specific framework. And even if it's cheap, if you want to move to another platform or another framework that is providing maybe additional features that the previous platform doesn't have, you have to do a migration, and migrations still take time and effort and coordination. You have to educate your team around the new conventions, new best practices, It's just not fully portable and framework agnostic. Agent Evals takes a different approach because there's an SDK, because SDKs can be nice. You have full control over what the actual code is doing, but it's fully optional. And it's really optional. You can use any kind of framework. You can be running on any kind of platforms. The only requirement is that you have OpenTelemetry compatible GenAI traces. When I say GenAI traces, I'm referring to the GenAI semantic convention, which is a part of the wider semantic conventions in OpenTelemetry ecosystem. Basically, they define how you should call the attributes that are describing your tool calls, the agent invocations, the LLM models, the providers, all this kind of stuff has to be following the OpenTelemetry semantic conventions. It's getting more and more stable. I would say nowadays there aren't that many breaking changes anymore, and most of the core functionalities are already covered with the OpenTelemetry libraries. So it's a reasonable foundation to build something upon. And the approach itself with Agent Evals was that we wanted to do something simple but hackable. So we provide all these various use cases and deployment modes. Basically, you can start on your local machine. You might be developing agents that are running on your laptop. So we also want to help with the local experiment during local development. So you can run Agent Evals, point your local agents to the Agent Evals backend. It's basically communicating through an OpenTelemetry endpoint. So you just point it like it would be, I don't know, your favorite OpenTelemetry destination. That can be, I don't know, Prometheus nowadays, or Datadog, or whatever that has a multi-app endpoint. There's a open source UI, so you can go to the UI on the port where it's exposing itself. And once you start chatting with your agent, on the UI in real time, you will see this communication happening in real time. So it's really easy to troubleshoot something and get some high-level idea about how is it using tools and what's the token usage. When you are chatting with agents and you are evaluating agents, you are mainly interested in what was the input, output, latency, token usage, what are the tools that are evoked, what are the tool agreements if you want to actually troubleshoot or dive deeper into how tools are working. And that's it. So the local open source UI can give you exactly this. You point your agents there and you see everything happening in real time. So it's easy to compare with a reference run or just see what's happening in your code as you are chatting with the agent. You can also deploy it in Kubernetes. So there's a Helm chart, and as I mentioned, it's an OpenTelemetry endpoint. So essentially, Agent Evals can be deployed in a Kubernetes cluster with the Helm chart. And in your OpenTelemetry pipeline, you can just point your exporter, your old ERP exporter, to the Agent Evals backend, and it will just work. On the live UI, you will see the conversation happening in real time, as you would see with the local experience, but your agents are running in Kubernetes. I will show you the integration example in the repository. I tried out integrating it with Kagent, and it worked without a problem. So that's something that is tested and should work still. So for this group, I think that's a fairly easy way to get familiar with the concepts and to try it out and see what kind of value it can provide. There are some limitations how this can work, because obviously if you have agents in production, you don't necessarily want to push everything to the agent evals backend. There's a 2 hours long TTL, so traces and evaluations will expire. Although we have started working on providing a durable storage, it will be backed by Postgres. So you can have like real durable storage for storing all this data. But the main currently well-tested use cases are local, not just local, but like small volume experiments, because we feel like, and based on experience, that's where the current community is. They just want to change things in their agents. They want to tune what kind of tools it has access to, what's the system prompt, what's the model, and they want to see the differences. So this is why we started with this stateless approach. It's quite easy and nice. It doesn't consume too much resources. You doesn't need to set up Postgres if you just want to test this out. In-memory works perfectly fine for most of the scenarios. And I will do the demo very shortly. And that will click everything into its place in the puzzle, and you will see how all these pieces fit together. There's also a CLI, which is great if you already have traces. As I mentioned, OpenTelemetry is the only requirement. So let's say you are using Kagent, you have your favorite Helm agent, and you have a good conversation with that Helm agent. So let's say you want to find out what kind of releases you have in your cluster. You want to get the values of one of them. And a good example or a good quality of a Helm agent interaction is when your Helm agent is actually using Helm commands to list the releases, to get the values. If you change to a new model, and after that change, your model starts to use kubectl commands to get you these answers, then you know that something is bad. In that case, certain evals will fail, because if your reference was that for your Helm agent to use Helm commands, then that's expected. And this is actually something that you can also leverage in CI/CD pipelines. So let's say you know what's the expected way of working for a given agent, and you want to ensure that there's no regression when you change things like the model, as I mentioned, or any other kind of stuff. In this case, in your CI/CD pipeline, you can add the reference run, which is something that we call eval set, and you can compare against that run in CI when you make changes, and you can have a gate failing if the actual eval is scoring lower than it was scoring before. You can specify the passing threshold basically, and you can gate your agents in production this way. There's also an MCP server support, because everything has an MCP server nowadays. So let's say you are sitting at your laptop doing a live local development with an agent, and you're using the UI to check the results, but you don't have 2 monitors, and you are doing all the development in cloud, for example. In that case, you don't need to switch between applications. You can do everything from cloud, because as you start agent evals and cloud in the same folder, it will auto-configure itself as an MCP server. It will expose various tools as MCP tools. So when your agent is writing itself, basically, if your agent is writing itself in cloud, you can do the evaluation right from cloud. So it's a very tight user experience and feedback loop, because you can iterate very fast. If you enable the auto mode or whatever Anthropic calls that nowadays, it can do the whole development phase, evaluating the results and iterating on itself, which is kind of nice. And you can also do online and offline evals. Online is a bit tricky, because even though there's the foundation of the durable storage already merged in open source, there's no real UI leveraging that feature. That's something that we have to add. So you cannot really do the online flavor of evaluation in a very nice way right now, but that's something that we are working towards. And we are focusing on the cloud-native ecosystem because I mentioned that OpenTelemetry is the only requirement. You have to have proper OpenTelemetry instrumentation, and in the cloud-native ecosystem, that's quite easy to get. I'm calling this out because some people have been asking, okay, can I use agent evals to evaluate Claude or Codex or open code itself? The answer to that question is that you can, sort of. Just before KubeCon, I spent one night to make it work with Claude because not many people know, but Claude also has an OpenTelemetry endpoint. It doesn't have proper traces, but it has an OpenTelemetry endpoint where it can export logs. And the logs have some kind of information that can be used for evaluation, but they don't have everything. So I actually had to add custom hooks. There's a few hooks, integration point in Claude code itself that you can use to enrich these logs. And I was able to get into the same shape where that agent evals expects. But it requires lots of code changes. It was an old branch. KubeCon was, I don't know, more than a month ago, maybe almost 2 months now. And the code and the project has evolved a lot. I've been meaning to update that branch and make it work again, just because it's fun to see Claude conversations in agent evals, but it's a different use case, and I wouldn't necessarily think that that's something that agent evals as a project should focus on too much, because you won't really have proper OpenTelemetry instrumentation in any of these coding agents. It's a different use case. These coding agents have their different eval frameworks and solutions. I made it work because it wasn't too hard and it was a fun experiment, and it was also fun to learn about the hooks system of Claude code. But probably the focus for agent evals will remain smaller, composable, OpenTelemetry ready agents that most of the enterprises and Kagent users are running already. That is truly framework agnostic and portable across platforms. That's the next slide about architecture. Do we have any questions at this point?
No.
I had
Go ahead, Evan.
Oh, go ahead.
No, I didn't think anyone had questions, but go ahead.
No, I was just going to say, if you had a chance to get to the UI, I had a question about that when we reach it. So I don't want to jump ahead, but yeah.
Absolutely. We are getting there. And this couple of slides takes a bit longer than I expected, but I think it might be useful to give you the full context of what went into the design and the use cases. But we are getting there. This is the third slide. And yeah, we only have this one, and that's the last. After that, I do the demo. This architecture diagram shows what's happening behind the scenes. Basically, we have agent on the left. You might or might not be using SDK. That's fine, fully optional. You point your agents to a tracing backend or a proper OpenTelemetry endpoint, or just use the CLI, and you provide traces as inputs. Traces are basically the transcripts of previous runs. Oh, and by the way, the reason why we went with OpenTelemetry and tracing is that traces are the only truly portable transcripts that are really portable across all the frameworks. Everyone has their own proprietary format that is specific to the given project, but traces with the OpenTelemetry semantic conventions is something that is truly portable. So this is why we built upon this foundation. So basically, you provide traces as the input. Traces will be turned into invocations by the eval engine. Invocations is a concept in ADK because behind the scenes we are using the ADK eval framework. It's a pretty lightweight framework. At least we use only a pretty lightweight part of it. Just these traces to invocations and then doing the evaluations. It has other parts that we are not really using, but this is the reason why we are truly portable. Anything that looks similar to traces, we take them, turn them into invocations, and invocation is basically input, output, and the tool calls and the intermediate data between all this. And then, based on that invocation, we can do the evaluation, which is some kind of logic or calculation based on the data that we have in the invocation. And you have various ways to explore that. You can use the CLI or the MCP server. So now, demo time. Let me try to do the demo. It's not extremely easy to manage everything. I have the environment here. Some of you might have already seen this, but this is Agent evals on the right.
I don't think you're sharing it yet.
Am I sharing it?
I don't see it.
No, I can't see it.
Cool, thanks for letting me know. Can you see it now?
Yes.
Yes.
Perfect. So what you can see here is Agent evals on the right and various terminals on the left. I will be only demoing one specific use case, the local experiment, but as I mentioned, if you follow the Kagent example, you will see something very similar to this. And if we have time and you have questions, I'm happy to explore other parts of the UI, but let's continue with the local experiment first. So I have this running locally on my laptop. So I will select this option. I'm developing an agent locally. I click on it, and I have this view where it's waiting for agent sessions. Here, I have my agent code. So I do something like UV run, and I'm running my zero code LangChain example. If you check out the repository, you will see that in the examples folder, we have a zero code examples subfolder. That's the recommended path forward to start experimenting with everything, because the examples here are not using any kind of custom SDKs. These are just using either the given framework's native OpenTelemetry support, or not even that if the framework doesn't provide that. In that case, it just has vanilla OpenTelemetry instrumentation. So all the other examples are also good starting points, but those are specific to how Agent evals SDK is being configured, and the whole point is let's not do that. If we can, let's just use OpenTelemetry traces. So in this case, I have my LangChain agent. I can run it. Basically, an agent rolling a die and checking whether the number is prime or not. Very simple. And as the conversation was happening, it was pre-scripted. We were seeing the conversation happening on the UI live, which is kind of nice because, as I mentioned, you can right away see what was the conversation, what was the user input, what was the tool call, what were the parameters of the tool call, what was the tool call returned. Then based on that and the LLM behind the scenes, what was the actual output of the agent, you can see everything quite nicely, which is very nice during local development. You can also see token usage and some kind of information that we are getting out of OpenTelemetry metadata. These are all hotel attributes. We could add more, but this is just a couple of them listed here. Cool. Then let's say I have another agent, for example, OpenAI agent, which is another framework. But you can also use ADK, Strands, Olama, LangChain, what else? Identic, there's a lot. And we have support, we have examples for most of them. So let me run an OpenAI agent as well. Same conversation is happening again, and on the UI, you can see the conversation appearing in real time. One nice trick that the UI is doing, and you see that the conversation is already finished, but this panel is still propagating or changing how data is visualized. This is because we are using an OpenTelemetry receiver. As I mentioned, you can point your OpenTelemetry pipeline to agent evals, and it will just work. But in an OpenTelemetry pipeline, you might know that we have batching, you can have more complex and advanced pipelines. And if you have batching, and you most probably have batching in production and in a real Kubernetes cluster, then you know that messages might appear out of order. And here on this UI, you don't want to see stuff out of order because that's part of the correctness. You want to understand what was the first question, what was the answer to that. So we are doing batching, but after the conversation finished and the batches has arrived, we are reordering them in the proper order so you can actually troubleshoot if you have any kind of problems. If you see messages out of order here, then there's a very, very high chance that there's something wrong with the agent code itself or the LLM itself. So it's actually kind of useful already at this stage of validating that the actual conversation has the correct flow that you would want to have. In this case, I have GPT-4o mini and GPT-5.4 mini. So it's not really apple-to-apple comparison if I want to compare these two. And also the conversation is kind of the same. So it's not the perfect example. Normally, when you're doing evaluation, you only want to change one thing, because if you change your framework and you also change the model, then obviously it will be very hard for you to pinpoint which change is causing a difference in quality. Normally, you want to run the same agent on the same network, on the same model, using the same sets of tools, same system prompt, and you only want to change one thing and evaluate based on that, so that you have a better chance of identifying what is causing the difference. In this case, it's not a perfect example, different frameworks, different models, but it's a good opportunity to see how different certain frameworks and models are at running the same business logic, basically. After this point, you have to choose your reference, and your reference will be your eval set, and that is basically the golden data, the golden run, the reference run that you want to compare against. So just by a quick glance, we can see that, for example, the OpenAI agents was using a tiny bit less tokens. So let's say I'm conscious about cost. I want to use this as my reference. So you click eval set, and then you can move forward to evaluation. In this case, you will be comparing your runs against this one. On the next page, you can do various things. You can choose what kind of eval metrics you want to run. You can check, for example, tool trajectory score, which will tell you whether both agents are calling the correct tools with the correct parameters in the correct order. You can use the LLM's judge flavors. You can check for safety. You can check for hallucination. You can check what was the final response compared to the eval set that you provided. You can do lots of stuff. That's what you can configure in this middle section. But another thing that you can do is that you can edit these transcripts live. So you have the two runs that I was running, LangChain and OpenAI, and I can click these and bring up this live editor, where on the right you have your raw traces, and on the left you have this editor where you can edit the actual invocation. And this is pretty useful because let's say you want to do offline evaluation in your CI/CD pipeline, but for whatever reason, you cannot get your agent to give you a bad quality answer. Or a better example, you cannot get your agent to give you a good answer, because that can also happen. Not all the LLMs are great for all the stuff that we are asking them to do. In that case, option one, you try as many times as you can. You can burn lots of tokens to get the answer in shape that you want, or you can use like editor like this, where you can actually and provide the final response that you want to use as a reference. Then you can later compare against that one. Obviously, editing a huge trace spans with lots of GenAI metadata. It can be a multi-thousand lines of long JSON file. Is not a great experience. So this is why we have this nice and easy invocation editor where you can cheat if you want or need. You can do the same for the eval set, basically. Everything is editable. Cool. Once everything is in place, you can click what kind of metrics you want to run. We are running out of time, so I will click the one that will take the less time. So the ones that is not using an LLM, we will just check the response match score based on the reference that we provided. It's a Python library running locally. It's checking the similarity between the other run and the reference run, and it will score how close it is in a similarity scale, and we'll get some results. Let's click run, and you see something like this. You can compare latency right away. So this is the LangChain example. This is the OpenAI agents example. You can see that the LangChain one was almost twice as fast, which is something quite significant. You can also use that token-wise, they are almost the same. So if you are more conscious about time, then for example, LangChain with this given example might be a better fit for you. Here you can see the actual scores for the evals that you were running. You can also explore the conversation again if you don't remember what was happening in the given interaction, and you can click on any of these and you see a drill down and you can understand why you are scoring the way you are scoring. You can see which metrics are failing. For example, in this case, the proper tools have been called, but the actual argument, the tool argument was different, which might be or might not be relevant for your use case. By default, ADK's eval framework will fail in this case, but this is configurable. So you can basically tune these and make them work for your specific use case. But with this view, you can pretty easily see why something was failing or why something was passing. That's the basic flow. As I mentioned, if you want to integrate this with Kagent, you can get a quite similar experience because you can let me open the repo. You can point your OpenTelemetry endpoint to the agent evals backend, and if you go to examples and go to Kubernetes, you will see how this could work and what the flow would look like. In this case, I'm chatting with the Helm agent. You see the conversation here. Obviously, this is a real example, so you have a lot more context and content here than in the synthetic other example. but the flow is very similar. You choose what you want to evaluate and you can run evaluation. It's kind of nice, and then you can see the scores. Yes, that was it. Happy to take questions at this point. I will stop sharing and answer questions if you have any.
I have one. First of all, thank you for showing that. That was awesome. I've been just playing with it myself this last few days, and it's really cool. So I appreciate that. Second of all, what you were showing, like in the last few minutes, like how you're like selecting which eval set that you would like to, run. Let's say the trajectory like against. Is it possible to I guess provide the user like a way to read, like to direct via like the browser URL, like directly to that specific trace ID if it's been loaded, like assuming, or no?
Like after you run the evaluation, you want to be able to have a URL that you can use and send it to your, I don't know, teammates where they can see the results.
Yeah, because I think I haven't yet done this, like but what I would want to do whenever I get it, like in our test cluster that we have, instead of having them go to that streaming page and kind of look for the one that I would want to just provide them a URL with a preloaded trace ID that gives them the ability to centrally like run for themselves and what I just did without them having to dig around like that. I might not have the right like phrase. Like
I also get your point, and it's very reasonable. And yeah, we don't have that at the moment. It's very tricky because everything has been in memory since the inception of the project. But now that we have the foundation for the durable Postgres-based Postgres-backed storage merged, we only really have to add the UI piece on top so that you can explore historical runs that have happened before. Currently, if you enable the experimental Postgres storage, which you can also do in the Helm installation, all the runs that you are evaluating will be stored in Postgres. So at this point, from a technical point of view, while you cannot give your teammates a URL, which is kind of nice UX, you can give them a SQL query that will give them the results, which is terrible UX, but that's the state where we are. Currently, we are focusing on other stuff. We are also really welcome contributions on the UI part to make this work end-to-end. So if anyone has 3 cycles and has a great eye for UI and UX, then we are more than happy to also collaborate with members of the community and deliver this feature. The foundation is there. We are changing some stuff on the storage side, but most of the core foundation won't really change. So it's something that we can start building on top and add these features. So the user experience is kind of nice because what you mentioned is probably one of the first things that people want to have once they deploy this and start to use this.
Thank you.
Yeah, absolutely. Any other questions?
I guess I have one more. I know that you're saying like whenever you have like the eval, you kind of like have it already loaded there, so you just make small adjustments and then rerun it. But do you have any in like what repo you might be testing this in? Any like reliable means of like providing like a fixture to mock the LLM to load it again and again the exact same way, or is that something that would be kind of overkill in your opinion? Like considering like what you're making the golden is something different.
No, it's I wouldn't say it's overkill. It's a different use case or a different requirement. So for example, as I mentioned, the foundation is built on top of what ADK by Google provides. And the way their eval engine works is that they are not using traces at all. They produce traces But the way they are evaluating is that you always have to rerun your agents. We wanted to take a different approach because in some cases you might not be able to rerun the agent. So for example, for the ADK framework, you have to point your ADK CLI to the agent module. So basically, the agent has to be written in Python and with the ADK framework itself, which is quite hard requirement. Like you cannot really go around that. And we wanted to provide support for all the frameworks, all the runtimes. So this is why we went with tracing, because as I mentioned, it's fully portable across all the frameworks, but you can only, like, rerunning the agent is something that you can only do if you own the framework, but that will inevitably limit you to a given framework because you cannot support all the frameworks without building some kind of monster. So it's a different use case. We are looking into how to solve that. So for example, there's a way, not a way, but the shapes and forms and APIs in ADK Python are shaped in a way that currently only local run is supported, and that local run is something that you need in order to do the evaluation in ADK itself. But for example, that shape is kind of similar to what you need and have for A2A. So what we are currently thinking about and looking into is maybe using an A2A remote runner where you are not tied to a specific framework. You can just use the A2A protocol to run or instruct an agent, get the results, and do the same kind of things. So the foundation is not really there yet, but something that we are also looking into and exploring currently.
Yeah, that'd be cool. Sorry, I have one more. Some of those other evaluations that you had that were more, I guess, that have a dependency on, was it like Google Vertex or something like that? Is that what? I don't have access to that, at least in my company, and I'm still like trying to find the right guy to give. But is there any other way to accomplish the equivalent of what is locked behind those without it, or no?
Good question. It depends on the actual. eval logic. Obviously, none of it, or maybe just some of it, are well documented enough that you might have a chance to replicating it. But you brought up a very, very good point about extending what's available outside of the core built-in ADKs, because you might hit some limitations if you don't have a GCP account. And I forgot to mention this, but let me share my screen again. But there's a, you should see my GitHub, right?
Yes.
There's a way of doing adding custom evaluators. So in the main repo, you might, you should see the main repo. And in the examples, there's the custom evaluators folder. And this is not the best example. Where is the best example? Because there's somewhere, maybe in docs, custom evaluators. That's what I was looking for. You can also bring your own custom logic, because you might want to add some performance-based evaluation logic or scoring, or you might want to replicate something that is closed source and not available due to not having access to that kind of infrastructure. In that case, you can build your own with Python or JavaScript. We can also add support for other languages, but language is not really a constraint anymore in the age of AI. Basically, in a very simple way and SDK, you can write an actual evaluator logic and load that into agent evals and run that evaluation. There's no UI support for these yet. So it only supports the CLI itself. Basically, you create an evaluator, an eval.config.yaml file like this. And here you can specify your custom third-party evaluation logic, which can be a local folder, or you can be something coming from a GitHub repository. If you take a look at the evaluators folder, then you see that in the evaluators we have added some kind of custom eval logics that are not part of ADK, the ADK framework by default. Some of it are very simple, like is JSON. Very simple. It will take the input and will tell you whether the final output is JSON or not. Very, very simple. You can configure it like this, and it will run inside the eval engine with all the dependencies that you provide. This is the actual code, like 50 lines of code. So that's one way to extend what is available by default. We have other more interesting stuff like regex matching, response quality, time efficiency. This is basically time and token efficiency are basically the performance metrics. These are, you can configure certain threshold for time and token, and if the actual interaction will use more tokens than the threshold that you provided, it will fail, which is kind of nice because in some scenarios you might want to be a bit more strict about how many tokens you can, how much token you can consume. So yeah, that's an important part that I missed. You can also bring your own evaluator. At this point, it's only supported through the UI, but we are looking into adding support. It's only supported through the CLI. We are adding support to the UI as well, but it's not as easy as some might think, because obviously these can take lots of different shape and form, and making sure that the UI is showing them in a nice and uniform way can be a bit more complex than just adding something that we know what it looks like, basically.
That makes sense.
Cool. We hit the limit of the time. I'm still available, so if you have any questions, feel free to ask. If people have to drop, I have one call to action. We don't yet have proper we are not dogfooding agent evals in Kagent yet, for example, in the CI pipeline. So if anyone would like to work on those kind of stuff, contributions are also welcomed to, for example, ensure that the agents are using the best possible models. You can tune their the tools that they have access to, like the default agents that we ship. You can tune the system prompt, and before this, you could only do this based on vibes and feelings, and okay, I think this is performing better. But now you actually have some actual data showing that, okay, this is the good reference run. If it's getting better, we can change it. If it's not getting better, we won't change it. So it's getting easier to reason about why I'm changing certain agent configuration. So that's another way to contribute. But yeah, any other contributions are welcomed. We also have a Discord channel, and we will be spinning these office hours out from the Kagent community call, and Agent Evals will have its own community hour series where we can chat about the roadmap, the current issues that we have, feature requests, cool use cases, this kind of stuff. So yeah, let's join the Discord channel so that you can get notifications about these events when they are scheduled. I don't have anything else to add. So yeah, thank you all for joining. Hopefully it was interesting and useful. The presentation took a bit more time than I originally wanted, but hopefully it wasn't too boring.
No worries. Thank you so much for demoing and sharing.
Yeah, cool. Thank you for inviting me and having me.
Yeah.
Thanks, Kirsten.
Okay, I think then we'll end it here. So,
Yeah, thank
Yeah.
you. Bye bye.
See ya.
Bye.
Thank you.